Good afternoon, everyone. Thank you for joining in. I guess this is one of the toughest slot after the lunch, but I'm pretty much sure we'll keep everyone awake and alive. We'll be covering quite interesting topics, but before that, I'll introduce myself. So I'm Paris, working with Google Cloud for past 4 years, and we'll be here with my colleagues. We'll be talking on interesting topics. So over to you, Indu.
I'm Indu. I'm a principal engineer in Wells Fargo and I'm a Zoogla. So yeah, we'll contribute to that and see how it goes.
Yep. My name is Anmol Sachdeva, and I'm part of Google since like 4.5 years or so. I used to work in Google Cloud, and recently I have transitioned to GTech.
Okay, perfect. So starting with the topic, so we have like what do we have in gRPC with AI. So before we even start, I know many of us would have gone through many sessions since the morning. So I'll not have a specific questions toward the gRPC, but maybe to set the tone, what is the familiarity that anyone or all of us have with building AI applications? Any raise of hands that if we have built any applications using AI or which leverages AI to improve the user experience? Okay, that's great. So, what has been like your focus areas while you've developed those applications?
So I primarily work for an inference platform, and it's kind of service thing. So what is the question that you want to ask?
So basically, like while building any AI first application, what has been the main focus area from the user's perspective or from the developer's perspective that
I can probably share a different perspective to it. So the platform that we offer, it's like an inference platform I mentioned, right? So we offer different type of functions which can be invoked for inferencing. There are HTTP ones, there are gRPC ones, and there is low-level streaming, which is based off WebSockets. So this it's similar to the topic, right? So basically, different users have different use cases, and based on that, the implementation is also.
Yeah, that's actually the exact point that we want to emphasize on. Like different users have different use cases and different protocols, different areas that they want to look into. And I would like to pick up an example, one of a use case that I came across. So for some conference, I've traveled to Netherlands and back in California. So there, I and Anmol were traveling, and we went on and tried using Waymo and Tesla. So their self-driving mechanism, and that's where while traveling through their cars, their vehicles, we realize like how smartly and efficiently it's trying to manage things. And back then, I was not able to correlate that, but today, while traveling from Bangalore airport to towards here, that's when I realized while I'm traveling in the cab, I'm trying to book something in the Amazon, and then it's taking some time to load some things, and that's when I was realizing that what if something similar time would have taken by the self-driving cars to analyze the traffic, or for the traffic to come in between, or to analyze signals, then things can go in any direction. So this is where it was interesting to see like how some of the very common use cases that we commonly use are using some interesting technologies behind the scenes, but we don't get to know about it. And I think the core magic that's happening is, of course, that we want to limit the latency part. But on that, maybe if there is some other thought you have while trying that out, Anmol.
Yeah, sure. So basically, that's an appropriate example for this forum. Let's assume that we are in some self-driving car scenario and we are on road. We need to have the light sensing done. There is a perception system that should be checking in different sources. Different cameras could be getting installed on the vehicle, and there could also be range detection systems, distance detection systems, detection systems. These systems essentially will be capturing data in real time, and unless we act on them real time, we won't be able to really have self-driving cars safely deployed on roads. This is where we will be prone to accidents, etc. So this really calls out for real-time processing power. We need to crunch in a lot of data, and we need to act upon that without any latency, any delays. gRPC has been one of the protocols which has powered streaming use cases for a wide variety of applications. Self-driving cars is also one of the applications we certainly can delve deep into. But the whole theme of this talk is that we need to understand what's the real-time engine for AI. We should not just be focusing on gRPC, so we will probably try to speak from our experience, what we can do beyond gRPC for what kind of different components or different problem statements, different protocols could be getting used, like server-side events could be appropriate for some, WebSockets could be appropriate for some. So I'll ask to maybe Indumathy for sharing some real-life examples.
Sure. Let's switch gears a bit because we've been talking about latency, we've been talking about real-time use cases, right? What if I'm having a credit card and I go to a shop, a POP, and then do a transaction. So maybe I have stolen the card from somebody and I'm doing a fraudulent transaction, but it has to happen real time because if the detection doesn't happen before the time that I complete the transaction, I've lost the money. The person who owns the credit card has already lost the money, right? So this is a crucial time. This is the very sensitive period. So it is like a couple of seconds, less than a minute mostly. All of these multiple, it's not just one single service sitting within that system. It has to be like multiple systems, multiple engines talking to each other, like in a tandem. They have to work together in tandem so that every transaction that I'm making has to go through all those systems to understand if it is a fraudulent transaction or if it is a legitimate one. For example, we will consider flow, right? Say I go and pay, and then immediately the POP detects it, and POP sends traffic to a payment gateway. So we'll have to see what will make sense here, whether it is WebSocket or SSE or it could be any other protocol or gRPC. So once the payment gateway receives the traffic, receives the payment transaction, what happens? So it could have multiple say flows triggered in parallel. It could all be gRPC because all these are backend systems. They have to be high throughput. They have to be low latency. So that is where we'll see all this services talking to each other in tandem, but in very, very low latency period. So that is where gRPC will come in picture. So from the payment gateway, we will have to send the transactions to different systems, right? For example, we have to send the risk management system. We'll have to send it to the location detection system, and we'll have to send it to the say there will be a model inference happening to detect if this transaction is a legitimate one or a fraudulent one because it has to return a score. Based on all these metrics, it has to decide in a very, very crucial time that this is a fraudulent one or not. And it has to block the transaction immediately. So, and there could be n number of other users sitting there watching over a dashboard. They could be analysts, they could be like risk people sitting there and watching the dashboard, and SSE could play a very crucial role there where it could send the events and then the dashboards will reflect all of those transactions that are being made. And so it is a mix of all these protocols. It's not like the one protocol fits all size, right? It has to be a mix of all these. It has to be a hybrid model. And gRPC cannot play well with every other use case, right? Or every other system that I talked about. So it has to be a mix of all. But then we do have pit stops here. For example, what if a connection breaks? What if something goes haywire? I lose the transaction. I actually lose the money because the fraudulent transaction has not been triggered and it is not kicked off any alert at all. Because when a fraudulent transaction is happening, the actual owner of the card has to get the notification that this is a fraudulent transaction and they have to approve or reject or block the card accordingly and immediately, right? So all of this has to happen immediately. So that is where we see that it is a hybrid model rather than just pinpointing on gRPC or WebSockets or SSE. So there could be some pit stops, but what do you think about the flaky connections, the packet drops? How do we handle that?
Yeah, so it's not just about this particular use case, but whatever answer I'm going to give is going to be applicable for other use cases as well. Fraudulent transactions really can get influenced by the decisions, actually can get influenced by the network. There could be congestion in the network, there could be some TCP packet drops. Now, if let's say we are using gRPC, then gRPC is actually strictly based on HTTP2 as of now. That has a head of line blocking issue. So this is where if let's say one TCP packet gets dropped from a particular stream, the whole stream will be getting blocked, and the subsequent streams will also be getting blocked unless the retransmission of the packet happens. So this is where, if we were to do real-time analysis of fraudulent transaction, then in that case, because of head of line blocking, we would not have been able to do. This is really a challenging issue that people are trying to solve, and hence some people have come up with improvements on the HTTP2 stack itself. HTTP2 stack actually uses TCP and TLS behind the scenes. The improvements have been done to introduce something called as HTTP3. HTTP3 is using a fancy protocol called QUIC, QUIC, that is essentially a UDP-based protocol, and that wraps up the TCP and TLS functionality into its own thing. And that removes the head of line blocking problem by not having interleaved, I would say, streams sent over the connection, but rather you have completely independent streams getting sent over the connection. When you send independent streams, let's say for one of the streams there was a packet loss or packet drop, then in that case, the independent streams that are not impacted by this particular packet loss can still be delivered, and hence there is no head of line blocking for the remaining set of streams, though until the transmission for the packet happens for the actual stream which got the packet drop, you won't be able to have that particular stream related response. So this is where a lot of improvements are happening. gRPC as of now is based on HTTP2. Likewise, WebSockets, we have an option to work with 1 and 2. But then ultimately with HTTP3 and QUIC coming into picture, there are no new protocols and standards coming, and there is a successor for WebSockets also that has come, which is called Web Transport. So Web Transport is purely based on HTTP3 and QUIC, and it takes the best of both gRPC, WebSockets, but it does have some challenges that probably we can touch upon. So this was the example from the fraudulent transaction perspective. Let's get back to our self-driving car scenario again. So I talked about a particular example wherein perception system is there, and that perception system is probably using some distance sensors, some light detection and ranging sensors. These are called lidar sensors in self-driving cars. Such kind of sensors are getting used. The information, let's say if it's head of line blocking, then in that case, it can really prevent car from having emergency brake applied when there is any object coming in its front. So that is where we can even switch from gRPC to something like MQTT or IoT sensor based protocols. This is where you can have the MQTT protocol itself act for some specific sensors and act accordingly. And it really depends, like there are different parameters one has to think about. There could be different components in the self-driving car. One could be red light system, wherein you are getting informed about, or you are getting feeds about which particular signal will have the red light or green light. That is where you can even have server sent event, wherein the red light indication or the green light indication is being sent as a signal to the car so that the car can plan accordingly and take the decisions. So it's not just one protocol driving the solution for a particular problem statement. The different sensors in your self-driving car will be using, some could be using MQTT, some could be using gRPC, some could even be using some message queuing systems, which could be very specific, like Kafka streaming, etc. There could be different streaming protocols as well getting used. So in nutshell, I would say flaky connections and the other problems that we see are not just addressable by protocols. We need to also have consideration into what the data size would be, what the data format would be. Like some protocols would not be having binary data, but JSON data, which could be very heavy for consumption. Even loading of that will introduce latency. When it comes to working with gRPC, since it's protocol buffers, we essentially save on because of it being a binary format. But there are challenges as well. Like if we again come back to the fraudulent transaction system thing, what if in your system design you have placed load balancer, you have placed CDN, you have placed web application firewall. Now, if we are talking about streams, web application firewall won't be able to intercept what is there in the stream, and it will be a blind tunnel for the stream to go through, and hence WebSockets won't be really a good fit with the web application firewall protection that you would have provided. Also, let's say we are considering gRPC, then at gRPC level, because it will be binary, let's say someone is trying to simulate a SQL injection attack because it's a binary protobuf. you won't be able to have WAF intercept that particular attack, and again, it will be a blind tunnel. So that is where there are different techniques that have to be applied for different components and different exposure layers. And yeah, with this, I think you can have some specific, I would say, examples related to maybe voice assistant or AI assistant or chatbots also. I think Paras has got some experience to talk about.
Maybe I'll try to
Yeah.
bring back to a more generic use case, generic like something that we use day in day out, and to correlate what we are trying to see. We've discussed a lot of jargons, a lot of deep technical, but let's try to dive into a more generic use case. So let's say as an end user, when I'm going and chatting to an AI system, I'm sending a simple textual prompt. So the way this request flow I could visualize is, and the reason I'm visualizing is so that we can then deep dive into certain sections. It's like as an end user, I've sent some textual data to using a client or a browser, which then gets routed to a gateway. Now this can get routed either using SSE or a WebSocket. It's completely onto the end user because we are not advocating for one specific protocol. Like Indu mentioned, like one of our folk mentioned, it's completely dependent on the use case, the problem statement we are trying to target. So let's say we have either SSE or WebSocket which sends the request. After that, the gateway has then initiated a request which basically initiated action onto the agent orchestrator. Now, this agent orchestrator has sent the follow-up request to a vector database or a model agent, which is expected to return the token, and then it reverse streams down the data back to us. So the way I can see is like for half of this architecture, when we are connecting from client to a gateway or a backend, we are using SSE or a WebSocket. But when we are reaching out to the internals, where we are streaming the tokens internally, or we are accessing the vector database, that's where I could see gRPC bidirectional streaming plays a very critical role, because that helps us to save a lot of compute power, a lot of our time, and we have more tolerance toward any accidental failures. Now, following that, the two areas that I would like to understand is, one is definitely the protocol buffer. This is like considering from the perspective of if we are starting from the beginning, how that helps us in achieving the high throughput, specifically emphasizing on the binary part, the lower size of it, and then the ease of using any languages or platform. And second could be the throughput aspect, like you mentioned for the fraudulent transactions or the autonomous vehicle, where we don't have sufficient time to wait and see when the transactions or the response will come in. The entire request that we have sent is put on hold. So considering that as a wider request flow, how do we envisage these two areas? So maybe you can take one by one turn.
Yeah, sure. So considering latency and throughput, since gRPC framework does support multiple protocols, and it's not just protocols. It also supports JSON, but it actually depends on what use cases we're targeting, right? So for all these backend services where the individual services want to talk to each other, it is better that we use the protobuf because they are not probabilistic like the LLMs, right? They're not probabilistic. They are deterministic and they agree well with the contracts. They have well-defined contracts. And once we see that there is a well-defined contract, it would definitely make sense to have the protobuf as the protocol rather than using JSON, because the moment we use JSON, of course, it is a string, it is going to occupy more memory, the latency will be high because it is a string, right? So, and we need to reduce all of these. Every millisecond does matter in all these critical apps. So what we have to do is accordingly decide based on the use case whether we want to go with protobuf or any other protocol like JSON or something else also. So in this case, if the contract is solid, if all the services which are talking to each other are agreeing on a contract, then it would make sense definitely to go with protocol. But then there could be some scenarios where, say, LLMs, right? They are probabilistic. They cannot actually understand. So in those cases, we could go for JSON, even though we know that it is going to occupy more memory, it is going to delay. But then it would make sense to use JSON. But there could be one more use case also why we want to use JSON. Because what if we want to go to a feedback loop? feed this data back to LLMs, and they have to understand, right? They have to understand what is this data about, why I'm learning this, and what is the outcome I'm going to give. So it has to train itself. So that feedback loop has to be it has to be understandable by the LLM, in which case protobuf doesn't make sense because it is all serialized, it's binary. So LLM will not at all understand. So in such cases also, the JSON format would be like apt instead of protobuf. So it's more like how we decide and based on use case, what approach we want to take. So it's more about that.
I think that answers the questions. But coming on the throughput side, Anmol, there's one more aspect I'd like to highlight. Like in the flow diagram that I've mentioned, I know this is like a hybrid architecture and sort of resembles to most of the architectures. But I would also like to quickly cover on the aspect of gRPC proxy or web on like, why can't, when I was proposing this solution, why should not I could have proposed using the gRPC right from the very beginning? Why move to the SSE or a WebSocket right from the very beginning and set up everything like a one thing sure shot, or like we are going to the hybrid architecture? So why is that a good approach? What challenges have we seen in our use cases?
Sure, yeah, it's pretty good question because most of the people really don't have understanding as to when to use which protocol or for which use cases. I'll actually answer your question, but I'll also reference the use case which Indumathy brought up. So we will go back to fraudulent transactions again. With respect to fraudulent transactions, assume that we have one user who is actually doing net banking and it's through browser. And that net banking is being done from a malicious user, let's say, so it's a fraudulent transaction that should be detected. Then we have another user who is using a mobile app or an app which has been developed using some native technology, using iOS, Swift, whatever. Yeah. Now, there is a difference in the way if we were to use the protocols for these two scenarios for the same fraudulent transaction use case. When it comes to gRPC, gRPC is actually not a good candidate for browser initiated transactions. It's primarily meant for server to server interactions. This is where people attempted to come up with something like a translation layer, which they called as gRPC web. That gRPC web is nothing but a client that can sit in your browser. And then you will have your browser pretty much make a request in regular HTTP, which will then be converted into some particular format. Then this particular request will hit your gRPC server, but before the gRPC server actually is hit, there will be some sort of sidecar proxy, like an envoy proxy that will be sitting, that will be making sure that the translation from HTTP1 to HTTP2 is getting done, or any other kind of translations that are required in order to respect the gRPC standard are being done before the actual call is sent from the sidecar to the main gRPC server. So this is where first thing we need to understand, browsers are not designed in a way to have gRPC related frames or headers processed. Also, when the gRPC response comes from the browser, from the server to the browser, there are some trailing headers which are added as part of the connection conclusion thing. Such kind of things also the browsers are not able to interpret. That is where gRPC web could be one of the protocols that you could go with or patterns that you could go with, but it's not really efficient. This is where I'll touch upon something wherein we could not be using, let's say, simple gRPC with I would say this HTTP2 kind of blocking. Rather, we can do a hybrid wherein we can instead move from protobuf, because that's a binary format that browsers don't understand, to something which is JSON compatible. So that's where we get into something called as gRPC JSON. Now, this is where you will have the browser generate the actual request in form of regular HTTP1 or 2, and then ultimately again there will be some sort of proxy sitting near the gRPC server, and that will do the transcoding. This particular transcoding is also essential if you are dealing with any kind of MCP servers, let's say, because MCP as a protocol has been built in mind using text-based interactions, because MCP client, when it interacts with servers, it works on something called as discovery services. It is able to list down the resources, the tools, etc., or the prompts that are there at the server side. Now, this is all happening based on regular text-based JSON, which can be interpreted by LLMs, which can be interpreted by clients, and they can really comprehend the information. If we change this to something which is gRPC powered, then again the transcoding layer will need to be introduced, because the actual prompt that you are writing is in natural language that will need to be translated into something like a protobuf, and then that is something that can be processed by the actual gRPC server. So this is where we get to understand that there could be scenarios in real world wherein protocols might have to be interleaved or might have to work in tandem. Another use case is agent to agent interaction that you might be having. So either you can have the MCP server interact with the upstream APIs via gRPC, like that is one possible pattern. The other is you have agent to agent communication, like the perception system and the processing system of the self-driving car both interact over gRPC, because first the data will be binary, so it will be quite quick for it to traverse. The second will be because there are multiple streams, you can actually have a lot of data sent on the same connection. But then there will still be some kind of issues when it comes to real-time or mission critical things like head-of-line blocking that I mentioned about, which could introduce some issues in the system or probably have delayed responses. So we have to think about such kind of things. So the net banking related example that I gave could have been solved by gRPC web, but then I would rather go with WebSockets. Why? Because WebSockets are natively supported. There is no translation required. With gRPC web, there will be some encoding, decoding required. So there is already 30-40% of overhead that you will have on the actual protobuf related payload. And that decoding encoding operation will also spike up your CPU cycle. So this is where ultimately it will be more work on the client side that you will need to do before dispatching the call. So why not use WebSockets, which also have the full duplex connectivity offered? So there is a rationale that you need to make, like client side streaming if required, then we can choose between gRPC and WebSockets. If it's just server side, then we can choose between server sent events, WebSockets, or gRPC. But then ultimately it depends if there are any, let's say, firewalls in place. If there are firewalls, since HTTP2 is getting worked on from gRPC perspective, but for, let's say, if we talk about web transport as the upcoming protocol, it uses UDP. Most of the legacy firewalls or enterprise firewalls will drop the UDP packets by default. So that is where, even though you have, from architecture perspective, designed your system to be most efficient, practically it won't work because your network packets will be getting dropped because of them being UDP and not being allowed by the traditional firewall. So it's not just about what you should use for a specific point solution. It is something you should see in integrated sense. We do have a lot of scenarios wherein the call could be coming using, let's say, gRPC JSON or using WebSocket. Then ultimately you will be having communication done using gRPC in the background. There are different use cases for which different kind of scenarios and protocols. Yeah.
Yep. I think before we open for questions, with just one statement, I would like to say, like, for many of us, our first web application would have been using an Apache Tomcat server. So coming from a place where we used to modify XML file and adding port numbers and updating localhost to point to something and then doing our first hello world, to a place where we are trying to figure out what is the best practice for using gRPC for AI and trying to bridge the gap. It's going to be an interesting learning journey. And the more we talk, the more we share, it's going to be only better. So I hope this was of some help. But if we'll open the forum for any questions and answers.
What is the port number for gRPC?
So gRPC essentially, like any other application, you won't be restricted on a specific port as such. It's pretty much like a function call that you are making. So you first have the protobuf through which you will be generating the stubs, and it will be pretty much like a package inclusion that you will need to do and go about using those stub related functions, etc. As such, there is no port restriction that you will be
It's any randomized dynamic.
Yeah, like it really depends on where you are starting the server and client, because stub is something that you can generate on client and server side. So like any application, like the socket binding thing that you start in the application, whatever you define there as the port is something that will be respected. So it's not really bound as such. So let's say you can go ahead and pick 40,000 people work.
By default, it could be 8,100, I guess.
It's not really bad, but when it comes to protocols like MQTT and all, there are some specific ports. Again, those are configurable at the ingress level. As such, you are not bound from port perspective on GRPC.
Thanks for the the amazing session. So as you were mentioning, as a part of the orchestration in an agentic AI component, there'll be feedback loops, especially in the reasoning aspect, right? When it is trying to communicate with multiple agents. So it's a mix. Sometimes it's a feedback, as you were mentioning, it is JSON. Maybe sometimes it's embeddings or some other kind of data types. So how do we choose like one protocol or other, if you can shed some light on it? Because it's truly a mix of a lot of things. As you mentioned in your conversation, it deals with like vector databases, also databases, and a lot of components, right? So how do we evaluate which one to go with?
So predominantly, if we go with vector databases, it is all about numbers.
Yeah,
It's all about
embeddings,
numbers.
vector.
So the moment we see all of that, it's just a huge data. And using JSON doesn't make sense at all.
Yeah.
So in such cases, we definitely go with protocol because it compresses, it is compressing it a lot. And since it is all about numbers and actually the deserialization and serialization works better with numbers rather than the plain string that usually comes up with prompts and then feeding it to the LLMs. But then the vector databases in specific, since they're all about numbers, protocol does make sense. But then when we are actually giving the feedback in terms of strings, which is not all the vectors that we store in vector databases, then in that case, I think we should go with JSON. And you could also argue that why don't we use the gRPC JSON? Yeah, gRPC. Yes, you could, but it all depends on how your use cases. You could use the transcoding gateway as well. Like I was like trying to put that out because the reason why we want to go for the protocol is because it is better with serialization. It is better with compression. But if your use case doesn't work well with that format, then you could use this format as well, like gRPC or from JSON. Have a gateway, have a transcoding done. Then you'll have a win-win there.
Okay.
I'll add a couple of more points to this. So I'll give you more perspective.
Let's say there is a gateway layer that you have. On that particular gateway layer, you ultimately will be having some sort of load balancing left, right? Now, load balancing by default will be a round robin load balancing, or there will be some sort of algorithm that will be getting used. Mostly the requests on regular load balancers get routed using round robin. Now, when it comes to gateway level round robin load balancing, generally there is a KV utilization metric that is produced for load balancers. That is the key value as to what request is coming and where it is getting routed. So that is where you will see a non-uniform distribution, and a lot of servers will be overwhelmed, whereas some of the servers could be underutilized, and because of that underutilization, those servers really will be running the resources and wasting the resources, whereas the ones which actually have overutilization or are overwhelmed, they will have queuing implemented. Because of queuing, your first time to token or TTFT, as we call it in this AI thing, will increase. So you will see huge spike in having your AI responses getting served. This is where if you follow native AI relevant or AI specific load balancing technique like KV metric based load balancing on the gateway layer, you will have equal distribution of the request on the load balancers, and generally they will tend to have the same KV utilization metric, and hence you won't have underutilization or overutilization issues, and you will be able to serve your models in a better sense. Second thing, when it comes to gRPC or any other protocol, there are other things also that you should be taking into consideration. Let's say your context window is too big and your tokens generated are also big in number. So if the response tokens are too huge that they cannot be tolerated by the client and server is just bombarding the client with a lot of tokens, there is a back pressure flow control in gRPC that can actually say based on the window frame
field that is there as part of the header that, okay, we will now pause any kind of packet coming from the server. Client will first process these packets, whatever it has got or received, and then it will resume the packet. Likewise, there is something which comes to connection migration. So if you are moving out of this particular building while the streaming is happening and your connection switch from the Wi-Fi to your regular mobile network or 3G or 2G, there is something called as connection migration that is now supported in web transport or quick or HTTP3 based. This is where, regardless of which connection you are getting joined to, you actually will be having between server and client something called as connection ID maintained. That connection ID will ensure that be it that your connection is changing, your streaming will not get influenced. Likewise, in SSE, if you have a connection drop, and you reconnect, the server events will start streaming again. But with WebSockets, the thing is a bit different. It will break the connection because generally WebSocket connections are sticky in nature. So you need to understand from sticky nature perspective, from token handling perspective, from the ingress data on the gateway layer. There are multiple factors which lead you to choose between different protocols.